we're going to talk about variables. Variables are really the core thing that we need to understand if we're going to be writing programs. Variables are essentially boxes that hold values, right? What are computers really good at? They're really good at remembering things for a long time. For example, Facebook still remembers what you did when you were 14 years old. So a variable is a way for us to store that data somewhere. And now that data can change. For example, we might have our Facebook status that we can then update. And so that's going to change over time. It varies, right? So this is also called mutability when we have variables that can change. What we're going to talk about today is the basics of variables and mutability, but we're also going to talk about variables that don't change, variables that are immutable. So in a normal language that you might run into, Java, JavaScript, Python, C, C++, something like that, most of the variables are going to be mutable. That is, they can change. There are some languages like Haskell, for example, where variables are immutable. That means that once you assign a variable a particular value, it can't change anymore. And we're going to see in a little bit why we might want that. So let's get started with the basics. We're going to take a look at our Python editor here, where we can write code. So let's just get started with variables. We're going to have a variable called x, and we're going to assign that variable the value 11. So this x space equals 11. The way we're going to pronounce that is x gets 11. So x gets 11, and then I could also write x gets 13. Now if we then say print x here, and I click run, going to print out 13. Why is that? Because the variable x was first assigned 11, and then was overwritten to have the value 13, and then we printed that out, and we got 13. We can actually see this here. We can run our debugger, so we'll click this to enter the debugger, and then we're going to step one line at a time through this code. So we're going to run the current line. We've got this little arrow here pointing at the current line. We're going to run that line, and now we see this variable explorer here in the Spider IDE tells us what variables we currently have. So we have a variable called x that is an integer because it's a number, and that number in particular has the value 11. So we have x of value 11, and if we click our run current line, you'll see our current line is now pointed at 4. So we're about to run line 4. We're going to run this line, and now we get 13. And if we run the last line, then prints out 13. So this is how our assignment works. Now let's look at what this looks like just on paper. So I'm going to write down this code. So we have x gets 11, and then x gets 13, and x. And what happened? We created a variable here in this line called x, and then we put a value into it. We put the value 11 into it. And then we go to our next line and we cross it out. We say, you know what? We don't want 11 anymore. Now we want 13 in that box. Now this is fine, but if we had a bigger program, for example, x gets 11, x gets 12, x gets 13. Now, how do we keep track of this? We're going to cross out the 13, then we're going to write 11, then we're going to cross out the 11, and we're going to write 12, and then we'll cross out the 12, and we'll write 13 again, and the whole thing is getting a little messy here. So I'll show you a different accounting method that we can use. So rather than writing a box, what I like to do is write a table. So I'm going to say, okay, this first line created the variable x, and we initialize it with the value 11. So we put 11 in here. And now I say, okay, I'm going to the next line. I'm going to cross out 11. I'm going to put 13 in here. And then I say, okay, run this line. Now I go to the next line, cross this out. And now I have 11, I cross this out. I have 12, I cross this out. I have 13. And you can see it's much easier here to track the history of how your variable has changed and what's happened over time. Now, this is going to help you when you're dealing with more complicated programs. Let's write a little bit more complicated program. We're going to write x gets 11, y gets 3, x gets y plus x, I don't know, y gets y minus 1, x gets x minus y. Okay, so this is the program that we want to run now. I don't know what the value of x will be at the end of this program, so let's test it out. So we're going to just read it like a book. That's what I like to say. I had a student, Eric Grine, and he told me, I'm just going to read it like a book. And that's what we're going to do. We're going to take this. We're going to say x starts with 11. Okay, now we've got a new one. We're reading it like a book, just one step at a time. Y, that has the value 3. Okay, we're going to this third line here now. We say x gets y plus x. So the new value of x, that's going to go right here. That's going to be the current value of y, 3, plus the current value of x, which is 11. So that will be 14. And let's cross that out. Now we say y. We can say y gets y minus 1. So the new value of y here is going to be the old value of y, is 3, minus 1. So that's 2. You'll notice what I'm doing here is the new value is on the left side of that assignment operator. It looks like an equal sign, but we call it gets. You say this assignment operator is gets. So the new value of the variable is on the left side, and anytime that variable appears on the right side of the equal sign, the assignment operator, we're using the previous value. So here we're saying the new value of y gets the old value of y minus 1. And then finally, the new value of x gets the old value of x minus the old value of y. So we're going to say the new value of x, which is going to go right here, is 14 minus 2 is 12. And we've successfully executed this program. So that's great. This is all really good. And, you know, maybe you don't believe me. Let's just let's check in our editor here. We're going to write out this code. We're going to say y gets 3, x gets y plus x, y gets y minus 1, and x gets x minus y. And let's run this step by step. All right. X gets 11. That looks good. Y gets 3. We're now going to overwrite x with y plus x. So now we've got 14, and you'll notice this matches what we had here. We're going to then run the next line. Y gets y minus 1. Now y is equal to 2. Then we'll run this last line. X gets x minus y. So now we see x is 12, y is 2. X is 12, y is 2. Great. So what happens when this is, so far we are using the debugger. I'm going to hit stop, and if I click run, all of this is going to execute really, really fast. So it's the same thing that we did. A computer does the same computation that we did. There's no surprises. It just does it much faster. So if you're ever in doubt, if you're ever confused, why is my program printing out some value that I didn't expect, slow down, read it like a book, and write out this table. If you write out this table and step line by line, it's going to tell you, you're going to discover what went wrong. Okay, so this is variables. Now let's go back to our little slides here. Things to remember. This equal sign, this assignment operator, that's pronounced gets. So when we see x gets 11, in our code here, x equals 11, we're going to say x gets 11. It's assigned the value 11. When in doubt, read it like a book. If you're ever in doubt about your code, just slow down and read it step by step. You're going to, just like math in high school, you're going to make mistakes when you're skipping steps. And then finally, number 3, this is what I didn't mention so far. Variables don't matter, but they sort of do. So let's go back to our code here. So far, I was using x and y as our variable names. If I renamed x to something like z, if I renamed y to z, And as long as I did that consistently, I'm still going to get the same result. Now, hold on, let me just clear this all. I'm still going to get the same result, right? So the variable name doesn't matter. I could even call this something like 4. 4. 4. 4. 4. Clear this again. We'll run this. Again, where you've got 4 is the value 2, just like z and y was before that. So the variable name doesn't matter. It actually doesn't matter at all what we call this variable, as long as we're consistent with how we use it. That being said, this would probably be a bad idea. You probably wouldn't want to call your variable, which is 3 and then 2 later on, the word 4. So this would be bad practice, but strictly speaking, there's nothing wrong with this. Okay, so this is what we have so far with our variables. These are our normal mutable variables that we would see in, again, a language that you're going to come across quite commonly, Python, Java, JavaScript, something like that. Now, mentioned earlier, though, variables in some languages don't change. Sometimes we call them identifiers, but they're variables. They're just variables that don't vary. Now, the question is, why would we want a variable that doesn't change? That seems a bit odd. Well, let's go to our, go back to our code. Okay, if we were to have variables that don't change, that means that we wouldn't be able to reuse the value y here. So, rather than x, I guess, we would need to say x1. And rather than y, when we update this, we would need to say y1. And rather than x here, we would need to say x2. And then also when we're doing that assignment, we're now going to be using the most recent value of x. We're going to be talking about this one specifically. So we'll say x1. And here we want the most recent value of y. So we'll use y1. And now when we run this all, you'll see we still end up with the same result. That last value of x is still 12, but this seems like quite a headache, right? We've had to rewrite a whole bunch of stuff here. So this is a pain, but could there be a reason why this exists? Well, let's take a look. I'm going to come up with a different program here. I'm going to say, I'm going to use something that we haven't done before, which is define a function. And this is a function that adds x to whatever value you pass in. So whenever I call f, just like a mathematical function, f returns y plus whatever x is. So let's say, we'll keep this as y1. So, or no, keep this as y. We're going to update y. Rather than just getting 3, y is going to get f of 3. So we're going to pass in 3 to this function. The y here becomes 3, and then we're going to return 3 plus x. So this y here should be 14. Let's just make sure we're not going crazy. Yes, x is 14 when we run this code. Okay, that is fair. I know we haven't covered functions yet, but just trust me on this for now. Now, let's say I change x. I'm going to say x is 10 now. And then I want to rerun this function f, again, with the value 3. Now, going to, let's do the, run the thing. Now, x is 10 and y is 13. Okay, this is a little, you might be getting a little bit worried because there's something a little funny going on here. Let's print this out to make sure we know what's going on. We're going to print out y. Oops. We're going to print out y, and we're going to print out x. And we're going to print these out again down here. We have 11 and 14, and then 10 and 13. So what happened? Well, we changed the value of x. So when we apply the function f here, now we're not adding 10, we're not adding 11 to y, we're adding 10 to y, and so 10 plus 3 is 13 rather than 11 plus 3 being 14. Now, this is concerning because this function here, this looks identical, right? Both of these lines are exactly the same, f of 3, f of 3. You might expect that if we write the same line of code, it does the same thing. But that's not the case here because we have variables that are mutable. And we have this kind of weird thing where this variable somehow gets passed in here and then we can change it and it's a big mess. If we weren't allowed to do this, if we had to give a new value to x the second time we wanted to use it, we would write our code like this. And now you can see our assignment of f of 3 is 14 in both cases. So this mutability can cause some readability issues in your code. And we're going to talk in more depth about this when we get to functions, but what's happening here is that this function isn't behaving like a mathematical function. In a mathematical function, again, from high school math or something like that, if we write, let's see, y equals mx plus b, right? And let's say this is 2 and b is 1. Right, this is our old function, and functions now are just like this. Right, so rather than y, we write f of x, and we're going to pass in x. So if we pass in x, every time we compute mx plus b, we're getting the same value out. It's not like this mathematical function can somehow change since the last time we computed our slope or whatever it is. But there's something weird here in programming where we do allow this to change when we have mutable variables. So this is just good to know that in Python, which is the language we'll be using for this class, we do have mutable variables, and there's some weirdness that might happen. Just because you've written f of 3 here and f of 3 here, these two functions might behave differently if something about the variables has mutated in between when you called your function the first time and the second time. And this is to avoid this confusion. This is why some languages like Haskell use immutable variables. Again, we're going to talk more about what it means for a function to either allow or disallow this property of having a different value when it's called on the same input in the future. But this is just something to be aware of, that variables are mutable and they can change, and that gives us a lot of convenience at times, but also can cause some issues. So that's all for variables for now. Next, we'll be looking at conditionals, and then in the future, we're going to be revisiting functions and trying to understand a little bit more of what it means for a function to really be a function in the mathematical sense.